And I'm Miss Julie, host of Saturday Science. And today, Tristan, what are we going to talk about?
The water cycle.
The what?
The water cycle.
The water cycle. What's the water cycle?
It falls down from the sky. It's rain.
Yeah, so when the rain falls down from the sky, that's part of the water cycle.
Yeah.
So there's multiple things that go with the water cycle. So when it rains, where does the water go?
In the dirt.
It goes into the dirt. Or does it collect in puddles or into ponds? Yes.
It's my flower pose.
Yeah, yes, it is your flower pose. Because flowers help to soak up all of that water. And then they breathe it out through transpiration, right?
Yeah, and then they bloom.
And apparently stab mommies in the face. Here's the deal. So, repeat after me.
Repeat after me.
Evaporation.
Evaporation.
Condensation.
Condensation.
Precipitation.
Precipitation.
Runoff.
Runoff.
No, don't actually run off. Collection.
Connection.
Very good. So there's 5 steps of the water cycle. So when the water heats up, like it did in our hot pot here, or in our tea kettle,
Yeah.
it can go from liquid to a gas, right?
Yeah. And then
Is that gas evaporation?
it's very
Yes or no?
Yes.
Yes, it is. And it's
it's-
very hot.
And it's steaming hot.
That steam is the water vapor evaporating.
Oh,
Yes. Now, from there, we have,
cold water.
yes, we do have cold water. So we have boiling hot water that just came off. We've got ice cold water.
Ooh, this is
We've got 2 mason jars. One at room temperature and one that was chilled because I was curious to see if there'd be a difference. Now, what we're going to do is we're going to basically make water cycles in a mason jar. Now, I added a little bit of blue food coloring to this one just because I could. I was curious to see if the dye would actually make a difference. So we are going to turn this so you guys can see it. And we are going to add
some cold water, maybe.
our hot boiling water. Super steamy.
Ah!
Ooh,
Oh, that's very blue. Hey,
it is very blue.
that's dark blue.
Make it even. Now, we can see all that steam coming off the top. So what we're going to do now is we're going to put caps on them. And we're going to seal that heat in. Now, Tristan, between the cold jar and the room temperature jar, do you see a difference?
Cold in there.
But what do you see? Do you see anything on the sides of the glass?
And there's steam just roaring out.
The steam is roaring around, but Tristan, you can see it moving in this jar.
Yeah.
But what do you see on the walls of this jar?
Nothing's moving.
Nothing's moving because there's actually little water droplets inside. And that condensation is already forming on the glass because it's cold. Now, if we take our ice jars and put them on top, we're just going to look. Because these are going to be really, really hot. You're not going to want to touch those. Here, I'm going to scooch these so then you can be seen. So, when we have these and we're looking at them, this might take a while to do, but essentially what we're doing, Tristan, is our hot water, it's already boiling.
Yeah.
It was already super hot. So we got the evaporation process done, right?
Yeah.
Okay, now we have to get into our condensation.
It's still hot.
Well, yeah, it is going to be hot. How about the top? Are they still nice and cold?
Yep.
Touch them.
I did.
Okay, now, check this out. So, notice, what do you notice happening inside of here?
Water.
The water's starting to drip down, isn't it?
Yeah.
That's because what we've gotten in here, Tristan, is that condensation or precipitation?
Condensation.
Well, the condensation, what happens is when that hot air rises, all that hot water rises up into the atmosphere, is it warm or cold up there? It's super cold. So what's going to happen is it is all that cold water, or all that cold air is going to cool down all of the water that evaporated. And then it's going to condense. Do you know what condense means?
No.
It means basically to grab onto it. So it's kind of like grabbing onto itself. So see how there's little water droplets on the outside?
Yeah.
That's because the little molecules are all slowing down, so they're able to hold on to each other.
Oh.
And then when they get to be so heavy that they can't stay up in the air anymore or in the clouds, what do they think that happens? Exactly, they fall back down. So that's what's happening right here. See how there's little droplets kind of raining down? That is precipitation. So it's raining in the jar.
It's not raining in the blue.
It's raining. It's not raining in the blue jar. No.
Very difficult.
I wonder.
If we had some salt in there. Let's add some
The
salt.
only thing, if we added salt to the water,
It will turn salty.
it will be salty, but it might actually make that water a little colder. I know that's weird, right?
Yeah, let's do it.
But I don't know, because this one's working really well. So a cold mason jar works better than a warm mason jar.
Ooh, and it's thirsty.
Well, yeah.
I touched underneath. What? All it's doing is falling to the pot. Oof. They're each making clouds.
Now it looks like it's raining salt. Okay, so looking at our two jars, Tristan, we've got our cold jar out of the refrigerator and the room temperature jar. Which one looks like it has made a better, well, basically a rainstorm? Which one is that?
The cold one.
The cold one. Now, that's because since it was already cold, it had a bigger temperature difference. So we were able to create condensation faster.
Yeah, that's...
Do you see any condensation in this one?
No.
Not really, no. So we've discovered, one, that using a cold jar works a lot better.
Yeah.
And using a room temperature jar, it'll eventually work.
Yeah.
Might just take a while. Now, looking at these as well, Tristan, let's run through the water cycle, okay?
Okay.
So we put our boiling water in here, and the boiling water, as it was steaming, was that precipitation or evaporation?
Evaporation.
Evaporation. When that hot air with the water in it touched the cold, like the cold air in the atmosphere, what did it do?
Condensation.
I'm sorry, what?
Condensation.
Condensation. It condensed. Condensation. It created condensation. And condensation is just when molecules basically stick together, right?
Yeah.
Yeah, in this case, are we talking about like strawberry molecules or water molecules?
Water molecules?
Yeah, we're talking water molecules. That's right.
Yeah.
So all those little water molecules started to stick together. Now, those water molecules, as they stuck together, they got bigger and bigger and bigger and bigger, right? So big. Could they stay up here any longer?
Nope.
So what did they do? They came down. What was the P word again?
Pre-K.
No, you're in pre-K. Precipitation. Say precipitation.
Precipitation.
One more time. Precipitation.
Precipitation.
Close enough. So, precipitation. No, you are participating in an experiment about precipitation.
Mama, it just...
Was there a little one?
Yep. There was a water drop.
Sweet. Oh, so it's just condensing on the lid. It's not condensing on the sides. Oh, that's kind of fun.
Yeah.
Cool.
Bonk, bonk, bonk. Ha! Get it? Not helping.
No, didn't help. Worth a shot.
Yeah.
So, as we've got that precipitation, it comes down in the form of what? Starts with an R.
Rain.
Rain. Now, if the air is really, really cold way up high, but warm down here, do you think we're going to get rain?
No.
Oh, snow is when it's cold all the way from the sky to the ground. If we get sleet, it happens when it's really cold up top and kind of warm down low. So that snow melts as it comes down.
Ooh.
Then we can also get the rain when it's cold way up high and then it's warm most of the way up.
Yeah.
So that's how we get rain, snow, and sleet. But tell me this, Tristan.
What?
Once we get our precipitation, what happens after precipitation? We got our evaporation, condensation, precipitation,
Rotation.
runoff.
Runoff.
Runoff, exactly. No, don't you run off. Come here. Oh, is your knee okay? Good. Okay, so with runoff, that's basically where stuff, say I was to take this glass of water and I was to pour it on your head. Wouldn't be very nice, first off, would it? But where would that water go? Would it stay on top of your head?
That would just go down my body and get my shirt all wet.
Exactly. That's runoff. Okay? So we've had all these big storms lately, right?
Yeah.
I know. It's crazy. So, breathe. So, what we've got is all of that rain coming down. And it's got to go somewhere, right? So, does it go off of our roof?
Yep.
And down our driveway?
Yep.
And through the roads?
Nope. And
Yeah, it goes into the roads and it goes into the drains, but it also goes into some of our neighbors' basements, and it goes into the swamp down the street, and it goes into the ditches around the neighborhood, and that water goes everywhere. It doesn't just go down the drains. So, say one of our neighbors had a whole bunch of fertilizer on their yard.
Yeah.
And we had our big rainstorm and it got washed away. Could that fertilizer go from here all the way to the Great Lakes?
No.
Yes. Yeah. Here's why. All of the storm drains are connected to the Great Lakes. That's why around our neighborhood in our city, we see all of these little pictures that say, "Do not dump leads to lakes."
Do not dump leads to lakes.
That's right. So that's our way of showing people that, at least here in Michigan, that all the wastewater from our streets isn't going anywhere but straight into the lakes. So we have to protect our lakes by picking up our trash.
Yeah.
And all of our leaf litter.
Yeah.
Compost it if you can. It's actually pretty easy. We'll do an extra episode on that at some point.
Leaf litter.
Right. And then we also want to make sure that we're minimizing how much salt goes on our driveways and in our roads during the winter. Because if there's too much salt in the water, is that going to change the habitat for the fishies here in the Great Lakes?
Yeah.
Absolutely. In fact, there was a study done last year that was saying that local, at least here where we live, that local water sources were actually becoming more salty. So they switched what kind of salt they used on the road to help reduce the effect on the native wildlife.
So the fish did not die and they swam off to another river.
That's right. They didn't die and they swam off to another river. Exactly, my darling. Now, with that being said too, Tristan, tell Mama this. Do you think that everybody should try and clean up after themselves?
Yes.
Yeah. Now, if, say, people want to wash their cars at home, should they use soap in the driveway?
Yes.
Wait, they should use soap? Wait, we just said that goes to the lake. Fish don't like bubble baths. Remember, they breathe the water. So should people use like a biodegradable?
Yeah.
Yeah, biodegradable soap, an all-natural soap, something that's not gonna hurt the environment.
Yeah, and they gotta like wash it down with soap. Like, no.
Special soap.
No.
Safe soap.
Spray it down with water.
With water. Very good.
Spray.
Now, Tristan, tell Mama this. Do you think that folks at home could also do this in a Ziploc bag?
Yes, and
yeah,
they were bloated. A couple.
Now, something fun to try at home would be to take two. You could do it in mason jars. You can do it in Ziploc bags, whatever. But one thing that would work out really well is if you had, if you had one bag that had clear and one that has colored liquid in it. That way, when you get that evaporation happening, we can see if those colors actually evaporate up or if they stay in our water source. So that'd be a cool thing to try at home.
Yeah.
But in the meantime, Tristan, should we sign off and tell everybody goodbye?
Goodbye.
But wait, before we go, what do people have to do?
Head on over to Patreon.
That's right. And do what? Subscribe to Patreon. And also, should they subscribe here too?
Yep.
Absolutely. Subscribe on YouTube. That way you can get all of our videos. And of course, hit that little bell icon so you get the first glances. Check out the rest of our links below, and we look forward to seeing you again next week. Thanks so much for joining us, guys.
Bye.
Bye.